Now, solving trigonometric equations, there are a couple things we need to remember. 8.4 trig equation. The period for sine and cosine, of course, consequently for cosecant and secant is 2 pi, while the period for tangent and therefore cotangent also is pi. Now, why I want to say that? Because, for example, if I have sine x equals to -1/2, for example, then what will x be? Now, the way we think is sine x hat, the reference angle, to make it positive. Okay, then what's the angle here in quadrant 1? 30 degrees, right? So sine is negative in which quadrant?
3 and 4.
In quadrant 3, what's the angle such that the reference angle is 30 degrees? 210, right? Okay, 210 degrees. And in quadrant 4, reference angle 30 degree, what's the angle? 330. By the way, Jeffrey, your voice is not really audible. I can't really hear you.
Oh, sorry.
No, that's fine. That's fine. I'm afraid that when you say something, I cannot really hear you. You know, I can hear you, but it's kind of like you didn't really speak to the microphone, maybe. Yeah, but you're fine. You're fine. I mean, I'm just afraid that if you have question, I don't hear you. Okay, now, but these two answers are the answers in the first period between 0 to 360. If I want to have all the solutions, including beyond angles beyond 360 or negative angles, then I will add 360 degree K plus 360 degree K. Okay, yeah, because the period for sine and cosine is 360 degrees or 2 pi. Now, on the other hand, if I have tangent question, let's say cotangent x equals to radical 3. So tangent x will be the reciprocal, right? 1 over radical 3. And it's in quadrant 1, 1 over radical tangent theta. Tangent x is 1 over radical 3, then x will be 30 degrees, right? But then I add 180 degrees K. Okay, now that's to explain the period. Okay, now sometimes they want the answer in radian, then you use 2 pi K, or in this case, plus pi K instead. Are you with me?
Yes.
Okay. Let me see how many people here. Okay. Now these are basic examples though. These are basic examples. Oops. Okay. Now let's go on to harder questions. For example, 1, solve for all radian. For example, I do number 14. Number 14, 2 sine squared x minus sine x minus 6 equals 0. Now, this is a quadratic-like equation, right? So I factor it. If it is not factorable, then you can use completing the square. or by formula. I think this is minus 2. This is 2 minus 2 plus 3, like that. Will that make it? Okay, so sine, it's surprising. Well, anyway, so sine x equals to negative 3/2, which means what will x be? Not apply, right?
Why is it not acceptable?
It's not acceptable. It's not applied because the range of sine, because sine x is between -1 and 1. This is less than -1. Likewise, for the same reason, sine x equals to 2, also not applied. So this equation, I picked a question that has no solution. So no solution. I think I copied the question wrong. My bad. I kind of see number 16 instead.
That turned out to be a good question then.
Repeat it again?
It turned out to be a good question.
Yeah. Yeah, even though we will see that anyway later. Well, anyway, let's say that's the question. Then when I factor, it turns out sine x. Once you see the value of sine x is outside of that -1 to 1, then we say no solution. Okay, now let me do the proper number 14. My bad. Okay, 2 sine x squared x minus 3 sine x plus 1 equals to 0. Now, suppose we solve for all radian. If I don't give you any instruction, I just say solve, then you can write your answer either in radian or in degrees. Okay, but you still need to have all solutions. Okay, now then I factor this. So 2 sine x minus 1 sine x minus 1. So sine x equals to 1/2. Sine x equals to 1. Is it right?
Yes.
Now when sine x equals to 1/2, what will x be in radian?
Pi over 6.
30 degree, pi over 6.
And,
Okay, and in quadrant?
Pi over 2.
5 pi over 6.
5 pi over 6, that's right. So this is the answer in quadrant 1. This is the answer in quadrant 2. But they must have the same reference angle. Now sine x equals to 1 means x is pi over 2, right? But these are the answers only in the first period from 0 to 2 pi. We need all the solutions. Okay, we need all the solutions. So I will add 2 pi k plus 2 pi k plus 2 pi k. Okay? So, repeat again? Yes.
Yeah, I don't understand how you get 5 pi over 6.
Sine x equals to 1/2. Sine is positive in two quadrants, quadrant 1 and quadrant 2.
Yeah.
In quadrant 1, that's pi over 6, right?
Yeah.
In quadrant 2, it must have the same reference angle.
Oh, okay.
Right? So then we need to give this angle instead. Okay?
Thank you.
Mm-hmm. this? That's for number 14. I think that number 14 is not too hard. Huh? Now, let's take a look on a slightly harder problem in which we need to start getting more careful with the domain of the equation. Number 18, for example, cosine theta plus 2 secant theta equals to -3. Now, notice that secant theta is 1 over cosine, so I can write this as 2 over cosine theta equals to -3. Is it right?
Yes.
Now then, I will multiply each term by cosine theta. I just try to get rid of the denominator. Okay, so I have now cosine squared theta plus 2 minus -3 cosine theta. Now, one warning though, because I multiply by cosine theta, it means my cosine theta cannot be 0, okay? And you notice that if cosine theta is equal to 0, it will make this part becomes undefined. Is that right? Okay, so, but we will check that later, at the very end, once we get the solutions, we just want to do a visual check, does it make it 0, like that, okay? And then I continue, I set one side equals to 0 because this is a quadratic-like equation. And then I factor with cosine theta plus 2 cosine theta plus 1. Cosine theta equals to -2. Now there's no solution for that branch, right? Cosine theta equals to -1. Then what will theta be?
Pi.
Pi plus 2 pi k. Okay. Now cosine theta is -1, so it will not be 0, right? So we are fine with that answer. Is it okay? Now let me ask you to try number 22. Number 22, secant alpha plus tangent alpha equals to radical 3. I think I need to do it together with you. It's 1 over cosine alpha plus sine alpha over cosine alpha equals to radical 3. This one I have to do it together with you. It's another style, something new. So I multiply by the LCD cosine alpha. Of course, this cannot be 0 later on. Okay, keep that in mind. Then I will get 1 plus sine alpha equals to radical 3 cosine alpha. And then if you have this kind of situation, you have sine and cosine, we try to make sine becomes cosine or cosine becomes sine.
Power 2.
Huh? What?
Do we take it to the power of 2?
Yes, in this case, because I cannot make it I cannot make sine becomes cosine or sine becomes cos. I can make sine becomes cosine. I cannot make cosine become sine also. Then the next option is I will square both sides. So yes, take it to the power of 2. Okay, with one warning. because we square both sides of the equation at one point, because I square both sides of the equation at one point, I'm sorry, then whatever answer I have later on, I need to check against the original equation, okay? 1 plus 2 sine alpha plus sine squared alpha equals to 3 cosine squared alpha. Now I have sine alpha, sine squared alpha, and cosine squared alpha. Who should I change?
Cosine?
The cosine squared, that's right. Okay, because I can rewrite that in terms of sine now, right? So this is 1 plus 2 sine alpha plus sine squared alpha equals to 3 times 1 minus sine squared alpha. Okay. Now I set one side equals 0, I get 4 sine squared alpha plus 2 sine alpha minus 2 equals 0. I can factor the 2 out. So I get 2 sine squared alpha plus sine alpha minus 1 equals to 0. You can also say you divide by 2 both sides earlier though. Sine alpha here, sine alpha here, plus, oh, I'm sorry, I need 2 somewhere. Let me put a 2 here. So 2 here, so plus 1 here, minus 1 here. So I get sine alpha equals to 1/2, 4 sine alpha equals to -1. Now, sine alpha equals to -1 means alpha is 3 pi over 2 plus 2 pi k, right? But I have to cancel this out. I have to cancel this out. The reason is because cosine of 3 pi over 2 is 0. Okay, because cosine 3 pi over 2 gives us 0. Okay. Now, going back to this one branch here, alpha is pi over 6 plus 2 pi k and 5 pi over 6 plus 2 pi k.
Professor, I have a question. So we have to avoid having the function to turn 0 and also be within the range of cosine and sine?
It has to be in the range of sine and cosine because otherwise there is no such thing, right? Like the one we have here, right? It won't be, right? Okay, so I mean, if you don't realize that, then you won't get the answer because there is no such answer. Okay, now on the other hand, I cannot take 0 here because earlier when I multiply by cosine alpha, it means cosine alpha cannot be 0. You see, here, you will see that 3 pi over 2 is not in the domain of tangent nor in the domain of secant.
Oh, okay.
Right? Because secant 3 pi over 2 will make it undefined. Yeah, but that's something you do after you're done with the question and then you do the visual checking. Okay, actually I will go. Yeah, I will go over this kind of question much later. Let me ask you to try number 20. Number 20, 2 cotangent square x plus cosecant square x minus 2 equals 0. I wonder how to do this. You do it, I do it too. You do it, I do it too. Okay. So from here, I split it. Cosine x equals to 1/2. Cosine x equals to -half. So what will x be?
I had a question.
Uh-huh.
What if I decided to change that two cosine square x and the -2 sine square x into -4 cosine 2x?
-4 cosine 2x.
Yes.
Not supposed to be -4 cosine 2x though.
Why?
Because it's not. Because it's not. You are saying 2 cosine squared x minus 2 sine squared x is negative what?
-4 cosine 2x.
It's not. It's not because I factor the 2.
Oh, I mean 2 cosine. Oh yeah,
but-
yeah, sorry. 2
Right?
cosine.
So this is 2 cosine 2x. Yes, you can.
Oh yeah.
Yeah, yes, you can.
What do I do?
I don't know. You want to do it that way, then go ahead. Yeah, you want to make it double angle. I have not taught you double angle. I'm about to teach you after this.
Oh,
Yeah, I'm about to teach you after that. But if you want to do it that way, it's not wrong. It's okay. But then How to treat the double angle, that's something else. It's not too hard though. It's not too hard. So far, I teach you the single angle for now. Okay, just to get the solutions correctly. So this is pi over 3 plus 2 pi k. Don't forget that. And then what else? 5 pi over 3 in quadrant 4, right? And then this one here, I get two solutions. 2 pi over 3, quadrant 2, and quadrant 3. Okay, now let's answer what what Jeffrey said earlier. Okay, Thomas, can I change that? Yes, using double angle. The answer is yes, you can. Now let me redo the problem down here. Let me redo the problem. I will take this guy. I will take this guy down here. Okay. So I have 2 cosine squared x minus 2 sine squared x plus 1 equals 0. I factor the 2 out. And we say, oh, the guy inside the parentheses is actually cosine double angle. Then from here, I solve for cosine 2x. Cosine 2x equals to -1/2. Now then, what will 2x? So instead of solving for x right away, I will solve for 2x. Okay, now cosine 2x equals to -1/2, then what will 2x be?
Pi over 6.
No. That's the -1/2. So it must be quadrant 2, 2 pi over 3, and 4 pi over 3. Now don't forget, I need to add 2 pi k, right? Now then, after that, divide by 2. So if I divide by 2, I will get pi over 3 plus pi k. Don't forget, you divide by 2 also, right? This guy divide by 2 also, right? This guy later on also divide by 2. Okay, so x equals to 2 pi over 3 plus pi k. Now, you will see that this solution that we have here, the solution that you have here, actually the same to the solution you have here. How can that be the same, Thomas? Now, let's take a look on the coordinate plane. Okay, now we have pi over 3, 60 degrees, and 5 pi over 3, 2 pi over 3, 4 pi over 3, right? All these 4. Now, notice that our solutions on the right-hand side here actually express it the same way. Notice that 4 pi over 3 is this one, right? But when you plus pi, pi over 3 plus pi will give you this one. As if this solution here, actually combine this guy and this guy. The condensation. And 2 pi over 3 plus together with 5 pi over 3 is being taken care of by this guy and this guy together. Okay, so going back, I tried to explain to you why these two solutions look different, but they are actually representing exactly the same thing. Okay, now, but I also show you through this second method that how do we solve double angle? or triple angle. Or let's say we have 3x here or 4x here. You solve for that first. Like what I did here, I solve for 2x first. Once I get the value for 2x, then I divide by 2 for the x. Is it okay? Nobody say anything. Let's do one more. Let's do one more, especially with the multiple angle case. Suppose I pick question number 50. Number 50. The question is solve for 0 degrees to 360 degrees. 2 sine squared theta minus cosine 2 theta equals 0. I think I will rewrite this first. That will be 2 sine squared theta minus 1 minus 2 sine squared theta equals to 0. Combine like terms, I get 4 sine squared theta minus 1 equals to 0. So sine squared theta equals to 1/4. So sine theta is plus minus 1/2, right? When I do square root, okay, when I do square root, I get, hold on, you know what? For this number 22 here, I make very big mistake. For this number 22, my bad. For this number 22, I make a very big mistake. I'm missing something. For this number 22.
Plus or minus?
No. I'm actually okay. I don't have issue with the plus minus. Notice that I square both sides in between. I square both sides in between, right? So I need to check my final answer. Need to check. I totally forgot that. I did say it though. That's why I use blue color. I did say it, and we're supposed to check, right? But I totally forgot to check that. You know what? What can I do now? Let me do it to the right hand side. Should I finish that last question first? You can do it yourself here, right? You can go on yourself here. But let me go back to that one first. I need to check this. It's a big no-no if I stop there. Yeah, so check. When alpha equals to pi over 6 plus 2 pi k. What's the question here? So secant pi over 6 plus tangent pi over 6, is it equal to radical 3? Now secant pi over 6 is 1 over cosine pi over 6. And cosine pi over 6 is, this is 2 over square root of 3, I believe, right? And tangent pi over 6 is 1 over square root of 3. Is it equals to square root of 3? So when I add them, I get 3 over square root of 3 multiply the top and the bottom by radical 3. That gives me 3 radical 3 over 3, which cancels to be radical 3 equals to radical 3. So that one checked. Now how about for alpha equals to 5 pi over 6 plus 2 pi k. So secant 5 pi over 6. I don't use the 2 pi plus 2 pi k anymore because they are coterminal. Okay, plus tangent of 5 pi over 6 is it radical 3. This will be negative because it's equivalent to negative of 2 over radical 3. And the one here, tangent in quadrant 2 will also be negative. After you compute this, you will get also this thing. So I get negative 3 over radical 3. Is it equal to radical 3 multiply by the radical 3 over radical 3? I get negative radical 3 on the left-hand side and 3 on the right-hand side. They're not the same. So the solution is only one. Alpha equals to pi over 6 plus 2 pi k. Okay, so only one solution for that. Because once you square both sides for any question, you need to check that. Okay, you need to check that. Now, I would like to do some problem from my trigonometry class because apparently this book is not does not have enough problems for you to work on. So let me take problem from my trigonometry class. So Manuel took my trigonometry class. This is what he encountered in my class. Let's say, for example, we get number 20. Well, for example, solve for theta from 0 to 360 degrees. Yeah. So what happened earlier? It seems like I have to finish the previous question. I'm sorry, I get distracted with that question earlier. So sine theta equals to 1/2, sine theta equals to -1/2. Now your solution here later on will be only between 0 to 360 degrees. Okay, so 30 degrees only, and then 150 degrees only, 210 degrees only, and 330 degrees only. So theta equals to, the solution will be 30 degrees, 150 degrees, 210 degrees, 330 degrees. Now, usually we put plus 360 degree K, right? But we don't do that here because they just want this. Okay? Because of that. Because we just need answers in between 0 to 360. Now, suppose I do this question. So for that, 2 cosine squared 3 theta plus cosine 3 theta minus 1 equals 0. What I will do, I will get the general solution first. what I will do, I will get the general solution first, and then I will squeeze that down. They squeeze it down. We squeeze it down to interval from 300 to 360. So let me solve that in general case first. I will factor this. It should be +1 here and -1 here. Right, so cosine 3 theta equals to 1/2. Cosine 3 theta equals to -1. Now then, I will solve for 3 theta first. Now you tell me what are the value here. Cosine 3 theta equals to 1/2, then 3 theta equals to, in degrees,
60.
60 degrees plus 360 degree K, okay? And then in quadrant 4, that will be
300.
300 degrees plus 360 degrees K. And this will be
180.
180 degrees plus 360 degrees K. Now, so far, we almost get the general solution. We almost get the general solution. Okay, but those are in 3 theta, right? I need to solve for theta. So theta equals to, for this guy, for 60 degrees divided by 3, that's 20 degrees plus 120 degrees K. 3 theta equals to, maybe let me pin this. Yeah, so this guy becomes this. And then this guy becomes what? So theta equals to divide by 3. What will happen? 100 degrees plus 120 degrees K. And the last one, this guy here, becomes theta equals to 60 degrees plus 120 degrees. Okay, but what we get here is called general solution. This is the general solution. Okay, now we will squeeze it down to the first period from 0 degrees to 360 degrees. How do we do that? And we start from when K equals to 0. What happened to the yellow one? Theta equals to what? For the blue one, theta equals to what? For the green one, theta equals to what? Theta equals to 20 degrees, right? For the yellow one, when K equals to 0. For the blue one, 100 degrees. For the green one, 6 degrees. Now, because the angle, the multiple is 3 theta, right? Then your k will be moving from 0, 1, and then 2. Okay? From 0, 1, and 2. Now, you can try 3 later on. You will see it doesn't work. Okay? Yeah. So when k equals to 1, what happened to the yellow one?
It's 140.
140. And then for the blue one, when k equals to 1, that will be 220.
220.
20 degrees. And then the green one will be 180 degrees. Then when k equals to 2, for the yellow one will be...
That's over the limit.
I don't think so. You
Oh,
have another 120, right?
280, 280. 260.
260, that's right. And then for the blue one, when k equals to 2,
340.
340. And the green one, when k equals to 2, 300 degrees. So then when k equals to 3, you see the yellow one will be 380 degrees, right? Which is too much. So we know we stop at k equals to 2. Okay? It does take some experience to know at what k you will stop. So if you don't know, Thomas, I don't know how far I need to go with my k, just keep on going. Keep on going until you go outside of that interval. Okay, keep on going until you get outside of this interval. Okay, does it make sense? Now, let me summarize. So the solution is, the solution is 20 degrees, 60 degrees, 100 degrees, 140 degrees, 180 degrees, 220 degrees, 260 degrees, 300 degrees, and 340 degrees. A lot, huh? There are a lot of solutions there. I strongly recommend you, if you have a chance, take a look in my old test 4. I mean, old math 241, test 3. Okay, there are a lot of good questions there. Okay, now I want to go over the question that I went over with you earlier, a similar type, the one that I have to square. Let me give one more question, like one similar question like that. Because I went over this with my trigonometric class, and I believe your teacher didn't do the same way. So I want to go over this with you also. Solve for 0 degrees to 360 degrees. For the question, sine theta minus square root of 3 cosine theta equals to 1. Let me move this to the right and then 1 to the left. So I get sine theta minus 1 equals to square root of 3 cosine theta. Basically, what happened is I have sine and cosine without square. So it's no way for me to actually convert one to the other. What I do then, I isolate the cosine or the sine, either way. So you can also do it this way. You can also have sine theta equals to 1 plus radical 3 cosine theta. And then you square both sides. Okay, you can do that. But I prefer the one on the left-hand side. I will square both sides. Now, let me ask you to do this step. When you square both sides, what happens? Okay, you do that also. When you square both sides, what happened?
Yes. Which one are we supposed to do? Both of them or just one?
Both of them on the left hand side. No, don't do the one on the right. On the one on the left, the one with blue color here. I want you to do the left hand side and right hand side.
Okay, you get 1 plus sine squared theta equals to 1 plus 2 square root of 3 cosine theta plus cosine squared theta.
Which one do you do?
I did the one without the blue.
Oh, you do the one without the blue.
Yes.
Oh, I really thought I said do the blue one. Okay.
Oh, sorry.
Okay, suppose you do that one. So you square this, you square that. So you should get sine squared theta equals to 1 plus 2 radical 3 cosine theta plus 3 cosine squared theta. You see what you get?
Yeah.
Okay, now then what do you do from there?
Oh, you're going to turn sine squared theta into cosine squared theta. 1 minus cosine squared theta. All right. Is that?
Yeah, so
Hello?
change this one here. So this is 1 minus cosine squared theta. Oh, we can cancel the 1, huh? That's really nice. Cancel the 1, so 0 equals to 4 cosine squared theta plus 2 radical 3 cosine theta. Now factor the 2 cosine theta out. Now for those who did the one on the left hand side, what you get?
2 cosine theta plus square root of 3 cosine plus square root of 3.
Oh, the one on the right hand side here. So 2 cosine theta plus square root of 3. That's right. So either cosine theta equals to 0 or cosine theta equals to negative radical 3 over 2. And then solve it from there. Okay, let me do the one on the left hand side. I know that's what I said earlier. Okay, so some of you do the one on the left, some of you do the one on the right. So there are 2 ways to do this, huh? I'll show you both ways at once. Okay, are you done, Jeffrey?
Yes.
Okay, so what are your theta?
I did the one on the right.
Okay.
Theta equals 0.
Huh? Cosine theta equals 0 means theta is?
0 degrees.
No, I don't think so. That's 90 degrees.
Oh, sorry, 90 degrees.
Right? 90 degrees. and 270 degrees. While this guy here will give us theta equals to
210,
210,
150 and 210, sorry.
150 first, and then 210. Now the thing is, we need to check one by one though. Yeah, we need to check, let's sine theta minus radical 3 cosine theta equals to 1. So when theta equals to 90 degrees, I get sine 90 degrees minus radical 3 cosine 90 degrees. Is it equals to 1? This is 1 minus 0, that's equals to 1. Let's check. How about 270 degrees?
Yeah.
Sine 270 degrees minus radical 3 cosine 270 degrees. Is it equals to 1? This is negative 1 minus 0. Is it equals to 1? No, it's not. And then how about 150 degrees? Sine 150 degrees minus radical 3 cosine 150 degrees. Is it equals to 1? Sine 150 is 1/2, cosine 150 is negative radical 3 over 2. This is 1/2 plus 3/2. No, it's not equals to 1. How about 210? Sine 210 degrees minus radical 3 cosine 210 degrees. Is it equals to 1? Negative 1/2 minus negative radical, minus radical 3 times negative radical 3 over 2. Is it equals to 1? Negative 1/2 plus 3/2. Oh, that's equals to 1. So let's check. So the solutions are theta equals to 90 degrees and 210 degrees. Is it right? Okay. What slows us down a lot is actually the checking, especially because we have 4 solutions here. Okay. Now, if you do the one on the left-hand side, then theta equals to 210 degrees and 330 degrees, and theta equals to 90 degrees. Still, you need to check, okay? You still need to check. But when you check, you will find that the answers are 90 degrees and 90 degrees and 210 degrees. Okay. Now that's the first method, and this first method happens to be 2 different ways. Okay. Method 1. Method 1. This is the most common method. This is the most common method being used in pretty much every textbook, including this textbook. Okay, but I want to show you another method. I want to show you another method. Method 2. Method 2, when we solve sine theta minus radical 3 cosine theta equals to 1. Now, this is what I will do. I will use, this is called unit circle approach. Unit circle approach. It is by doing the following. Suppose I have a unit circle. Suppose I have a unit circle and I pick a point on that unit circle. Okay, suppose the angle here is angle theta. Then what is the coordinate here? I wonder if you remember this.
XY.
Yeah,
I mean-
well, yeah, xy, that's right. But then can you express xy in terms of theta?
Cosine theta, sine theta.
It's cosine theta, sine theta. So here's what I will do. I will substitute sine theta and cosine theta by y and x respectively. But at the same time, I say they have to be on the unit circle. Okay, so I will solve this system of equation. I will solve y minus radical 3x equals to 1. At the same time, it has to be a unit circle. Are you with me? That's what I will solve. Okay, that's what I will solve. The thing is, you don't see this technique in our textbook. That's why I want to go over that. Now then, for the first equation, I will rewrite it as y equals to 1 plus radical 3x. Right, for equation 1. And let me square both sides. So I get y squared equals to 1 plus radical 3x being squared, that is 1 plus 2 radical 3x plus 3x squared. And then I plug that into the second equation. So x squared plus y squared, which is 1 plus 2 radical 3x plus 3x squared equals to 1. Can you follow me? This is my y squared, this is my y squared, this is my y squared. Well, we are lucky that the 1 cancels, right? So the 1 cancels, I end up with 4x squared plus 2 square root of 3x equals to 0. I factor the 2x out, I get 2x plus radical 3 equals to 0. So either x equals to 0 or x equals to negative 3/2, radical 3/2. Now, are we okay so far?
Yes.
Now I will find the x. I found the x, I want to find the y. So from this y here, if x equals to 0, what's the y?
1.
1. So the coordinate associated to this, sorry, this is 1, is 0, 1, right?
Yeah.
Now, 0, 1 corresponds to what angle?
No. Angle 0.
No, 0, 1 is here.
Angle 90. I keep saying.
90 degrees. Okay, now I go to this guy. Y equals to 1 plus radical 3 times negative radical 3 over 2. Y equals to 1 minus 3/2. Y equals to negative 1/2. Now the angle, so the coordinate will be negative radical 3 over 2, negative 1/2. Now what's the angle? Negative radical 3 over 2.
210.
210. Right? Now the nice thing about this technique, you don't need to check. The nice thing about this technique, I don't need to check.
This is way easier than the first method.
Yeah, I think the reason it becomes a lot easier because we don't need to write the sine and cosine thing. You know, and of course, I don't need to check. Even though the routine of checking is actually, it's okay. I mean, it's not too hard to do the checking. But if you have 4 candidates, I have to check all 4, right? Which is,
So yeah, and for exam, for a limited time, yeah, it's
that's right.
hard.
Yeah, that's right. That's right. Now the thing is, another reason why I tell you this, show you this method, because it is possible we don't get a nice numbers. Let's say, suppose for examples, if I have sine theta minus cosine theta equals to, let's say, 0.7. I don't expect this to be a nice number. I don't expect this to be a nice number. Okay, and using the first method that we did earlier, it will be a lot harder, especially because we need to check. Okay, but with what the technique I showed you just now, then this is y minus x equals to 0.7, x squared plus y squared equals to 1. That's what you need to solve. Okay, now this then becomes y equals to 0.7 plus x. So this expression then becomes x squared plus 0.7 plus x being squared plus equals to 1. So x squared plus 0.49 plus 1.4x plus x squared equals to 1. 2x squared plus 1.4x minus 0.51 equals to 0. What I will do next, I will solve using formulas. So negative 1.4 plus minus square root of 1.4 squared minus 4ac over 2a. This is minus. So plus 1. 1.02 plus 4.08 over 4. So x equals to negative 1.4 plus minus square root of 6.04 over 4. And from there, I have x equals to negative 1.4 plus square root of 6.04 over 4. The other branch is negative 1.4 plus square root of 6.04 over 4. Again, the nice thing about this method is I don't need to check anymore. If I need to check, once you have rounding error, when you check it, you will never get exactly the same number. That's the thing. Okay, I will use my calculator, negative 1.4 plus square root of 6.04, whatever the answer, divided by 4, give me x equals to 0.26441. And then, I need to go back pretty far, huh? I will use this one here. So my y is, what's my y again? 0.7 plus x, 0.7 plus 0.26441. That is 0.96441. So the coordinate is 0.26441 0.96441. The radius will be 1, but how about the angle theta? Now then, angle theta will be tangent inverse of the y over x. Supposed to be equivalent, not exactly equals, because we don't know. We know the theta will be in quadrant 1. We know the theta will be in quadrant 1. And tangent inverse of positive number will be in quadrant 1 too. Tangent inverse 0.96441 over 0.2644. I get the theta here is 74.66810 degrees. Jeffrey, you have a question earlier?
No, so I was just saying when you use the tangent, it's going to give you the values you need anyway. So
In this case, but you see that we will not get what we need if these both are negative. If both of them negative, supposedly, when you divide, it becomes positive, right?
Mhm.
And tangent inverse will give you quadrant 1, while we know if we have negative, it's supposed to be quadrant 3.
Oh, okay. So we
Okay.
just keep in mind that when we
Yeah, so suppose I have negative, right? So I
Yeah.
get this, and then I get this angle. I need to add 180 degrees.
Yeah.
Yeah, okay? Basically, you do the adjustment later,
Okay.
okay? Yeah,
Yeah.
but we get the angle first. And then adjust that. Now, I will give you a break, but I want you to also solve this. This should take you around 3 minutes. Together with you break, we come back at 6, let's say 6:18. Okay, let's make it 6:20. Why not? 6:20, we come back.
Is that radical 2 and 4 on the left corner of the radical?
What?
Is it radical 2 and on the left side of the radical we write 4?
No. No, 2 to the negative n is 1 over 2 to the n. This is 1 over 2 to the n.
I thought it was 2 to the power of 1 over.
No, no,
wait,
no.
never mind, never mind.
You just say that. Okay. Oops, I forgot to stop the recording. My bad. I thought I stopped recording. So the first term will be 1 over 2 to the 1, right? Plus the second term, 1 over 2 squared, plus the third term, 1 over 2 cubed, plus the fourth term, 1 over 2 to the fourth, which is, so you see, this is S subscript 4, the fourth partial sum is the sum of the first 4 terms. Right? Okay, now then, this is 1/2 plus 1/4 plus 1 over 8 plus 1 over 16. I wonder if you can simplify that. The LCD is 16, 8 plus 4 plus 2 plus 1, that's equals to 15 over 16. Okay, now this n partial sum can be written in sigma notation, in summation notation, as S subscript 4 means the summation from n equals to 1 up to 4 of the sequence. Okay, so suppose for example, how do I express then S10? Then S10 will be the summation from n equals to 1 up to 10
10. Why not?
of a subscript n. Mhm.
No, never mind.
You don't have to use n though. You can use k, you can use other letters. So for example, you can use k here from k equals to 1 to 10, as long as your indexing is also k. Okay, now the notation we have earlier up there, suppose then we have what is the sum n equals to 1 to 4 of 2 to the negative n. And that basically means this is the sequence. That's the sequence. This is the starting n, and this is the ending n. Okay? Now, it will be 2 to the power of negative 1, okay, plus 2 to the negative 2 plus 2 to the negative 3 plus 2 to the negative 4, and you stop there. That's what it means. Okay, so it's more about you reading the notation. It's about you reading notation. Now, let's see. Suppose I give, for example, the sum from k equals to 2 up to 6 of 3 minus 2k. So your k start from?
2.
Start from 2. Okay, so when k equals to 2 is 3 minus 2 times 2. That's the starting point, right? And then you keep on adding that term to 3 minus 2 times 3 up to k equals to what? When do I stop?
6.
Where I stop when k equals to 6. Okay, so I follow the same pattern for 3 minus 2k, and the k is moving from 2, 3, 4, 5, 6. Now then I go on computing this. This is negative 1, right? 3 minus 4 is negative 1. 3 minus 6 is negative 3. 3 minus 8 is negative 5. Right? 3 minus 10 is negative 7. And 3 minus 12 is negative 9. Then I get negative 25. Okay, you try this. The next example. how about the summation from n equals to 1 to 3 for n minus 1 times x to the n minus 2. Okay, you write it down. I don't think you can compute it because you have x here, but at least simplify. Okay, give you 1 minute. Okay, let's see. What is the first term? One minus 1, x to the 1 minus 2, right? When n equals to 1, this is my 1, this is my 1.
0.
And then let me write it down first, right? Okay, so plus 2 minus 1, x to the 2 minus 2, plus 3 minus 1, x to the 3 minus 2. That's right, this will be 0 plus 1x to the 0 plus 2x to the 1. Now, what is 1x to the 0?
1.
1.
1, okay. Because we assume x to the 0 equals to 1. Okay, even for x equals to 0. Well, actually 0 to the 0, actually 0 to the 0 is not equals to 1 and not equals to 0. Okay, it's actually undefined. It's actually undefined. Okay, but for polynomial, this kind of sigma notation, there's a convention x to the 0, we will just call that 1. Okay, plus 2x. Is it okay? Now, how do we go backward instead? Suppose on the other hand, I give you a sequence. Let's say 5 plus 5 squared plus 5 cubed all the way to 5 to the 10. How do we write this in sigma notation?
This is going to be k equals 1. It stops at sigma 10, and
Okay.
it's 5 to the n.
N or do you use N or K?
5 times n. No, 5 to the n. 5 to the n. No,
N?
no.
Are you sure?
Yeah, isn't it 5 to the n?
Almost right.
5 to the power 1 to plus to the power 5 to the power 10. I have no idea.
To the power of K. Because you use K here.
Oh, okay.
Yeah, use K there, right?
Oh.
Okay. So if you want to use N, that's fine. You can use N, but it means your K, you use N as your index. You see what I mean?
Mhm.
Okay. Or you can also use T. T equals to 1 to 10. Then this will be 5 to the T. That's okay. Either one. Okay. Now, but what about if I have this thing? 5 plus 5 squared, 5 cubed, all the way to 5 to the n. Then that will be summation. What is your index?
N.
Don't use n, because your n here will be the ending. That's
K.
where you stop.
K.
Okay. So use other variable. Let's say k. You see what I mean? So this, the same to this, your indexing is k. Oops, what am I doing? Your indexing is K. Okay, let's go on. Let's go on. How about if I have, let's say x plus 2x squared plus 3x cubed all the way to 7x7. What will that be in sigma notation?
One. I don't know.
We start from what first?
Start from 1,
Okay, we start from 1. Let me use k equals to 1 up to
7.
7. Okay, what is the pattern?
Isn't it like, I don't know, k minus x to the k or something?
K times
Times x
to the
k.
k. That's right. Yeah, that's right. What if I modified that a little bit? I make it, let's say I make it like this. I make it 1 minus 1/2 plus 1/3 minus 1/4. Okay, all the way to minus 1/10. Now notice that the first one is 1/1, right?
Yeah. Oh, this one's
Okay.
actually. This is 1 over k. Ends at 10, starts at 1.
Okay, so we start from 1, ends at 10, and something over k, you say?
Yes.
Yeah, but how about the alternator? It's plus minus, plus minus, plus minus. It would be
Negative
negative
1 to the
1
power of n.
don't use n, the index now is k
Okay.
to the k. But when k equals to 1 is negative, if you write it this way.
K
So make
minus
it
1.
minus 1 or k plus 1, either one is okay. Okay. So this notation can also be written if you use n from n equals to 1 up to 10 of negative 1 to the n minus 1 over n. Is it okay? Now I have 1 minute left. I forgot to do recursive example. Let's say I do number 16. Number 16, a sub 1 is to a sub n equals to square root of the previous term squared plus 1. And the instruction is write the first 5 terms. Compute the first 5 terms. Compute the first 5 terms. So you see the first term is 2. That's easy, right? That tell us. The second term will be the square root of the first term squared plus 1. What will that be? Square root of 2 squared plus 1 is
Square root of 5.
square root of 5. Then the third term is the square root of the previous term plus 1. What will this be?
You know what does 8n minus 1 mean?
Means the previous term before the n term.
Oh, that's why. Okay.
Right? Yeah. So if the current term is a sub n, the previous term is a sub n minus 1. Just like a sub 4, the next one is a sub 5, the previous one is a sub 4. So you see it's about notation, right? You need to understand what the notation is. Okay, what is the third term here?
Square root of 6.
That's right. How about the fourth term?
Square root of 7.
Okay. How far do I need to go? Oh, 5 terms. So the 5th term will be
Square root of 8. Oh,
square root of 8. That's right. Huh? Yeah. The fact that you can simplify, that's something else. Okay. But I will write it as square root of 8 first, and then I simplify. Okay. So the first 5 terms here will be, so the first 5 terms will be 2, square root of 5, square root of 6, square root of 7, 2 have equal 2. Or you can just leave it as square root of 8, that's also fine. Okay, now I hope you see that what happened here in this section is really the introduction into notation. So suggested homework, I don't need you to do a lot. 13.3, I would like you to do number 1 to number 21. And then 33 to number 61, but just do every other odd. Okay, just do every other odd. Yeah, because it's really introduction to notation. If you feel, if you enjoy that, feel free to do more. Okay, but I don't think it is necessary, at least for now, though. Okay, that's for today. Again, I would like you, between today and Thursday, I would like you to do your suggested homework. And yeah, I would like you to do your suggested homework and watch the lecture video from my Math 241 on solving equations and law of sine, law of cosine. Okay.
Okay, thank you, Professor.